Welcome back. Today we're going to be going over the next lesson, which is 1.3. And once again, if you haven't watched 1.2 yet, I'd highly recommend that you do, so you don't seem lost in future lessons, right? Um, without further, right, I don't want to waste any of your time. Let's just get started. So today we'll be talking about collinearity, betweenness, and assumptions. Um, actually, I already kind of mentioned about collinearity kind of in 1.1 when I talked about collinear points. So it is going to be more of a review. But again, it's good to like fresh up on knowledge that you already know, right? So it's more embedded into your head. But let's start right away. So what is collinearity, right? What does that even mean? Well, again, just to review what we kind of mentioned in 1.1, uh, points that lie on the same line are collinear, right? They're called collinear points. So likewise, if points don't lie on the same line, then they're non-collinear, right? And I kind of mentioned points here, right? But the truth is, like, uh, lines can also be collinear, right? And so can segments. But just because it's easier to understand when you're first approaching this concept, think of collinear points when you think of collinearity, right? Two things that lie on the same line, right? Just to kind of give you an example of how lines can also be collinear, right? Or like segments, how they can be collinear. Let's say I have a segment here, right? And let's call this segment AD. Actually, let's do segment AF, right? Now, let's say there's actually those points, right? Let's say there's B, C, and D, that kind of lie on line AF or segment AF. So in this case, right, segment BC and segment CD, well, they're actually going to be collinear segments because they lie on this entire segment, right? Um, Hopefully that was intuitive, but again, right, points are not the only things that can be collinear. Segments, right, or lines can also be collinear. So moving on from that, right, the natural continuation for collinearity is betweenness, right? And as you can probably tell, right, you see the word between inside betweenness, right? So it has this entire concept has to do with how certain points can be between two other points, right? And in order for us to say that a point is between two other points, um, all three of them, like they have to be collinear, right? And kind of get to give an example of that with a visual, right? If you look at the bottom here, right, you see segment AC, right? And in addition, you also see actually point B that lies on the same line as A and as C, right? So all these points are collinear. Now, because, right, all these points are collinear, you can go on and conclude that point B is in between A and C, right? So yeah, that's what I've written here, right? B is between points A and C. And remember, again, you can only assume that because all three of them are collinear. In contrast, if you look at this right here, right, you have points X, O, and Y, right? And they are not shown to be on the same line, right? They're non-collinear. Because they are non-collinear, you can't like make the assumption that point O is between X and Y, right? Even though it kind of looks like it is, right? Again, you can't assume that O is between these 2 points because they all have to be collinear first. So to simply kind of summarize this, right? When you're looking for a point that's between the other 2 points, first determine that all of them are collinear, and then you can go on and say that they are between or a point is between. Next up, we have the triangle inequality theorem, right? And this one is pretty cool, right? Is because it basically determines what a triangle can be, right? or like it determines like um, the sides that make a triangle occur, right? So to state this theorem, right, essentially the sum of the lengths of any two sides of a triangle is always going to be greater than the length of the third side, right? And this is true for all three sides of the triangle, right? If this theorem is violated, then that means a triangle can't exist, right? So the sum of the lengths of two sides has to be greater than the third side. And kind of just to apply that to our actual triangle, right? You're given a triangle with sides 11, 14, and 24. And if you want to apply this theorem, right, to prove that this is actually a real triangle, um, what you do is just make up three inequalities. So, like I said, it's the sum of the two sides that have to be greater than the third side. So that means if you do 11 plus 14, right, the sum of those has to be greater than 24. If you do 11 plus 24, the sum has to be greater than 14. And if you do 14 plus 24, it has to be greater than 11. And of course, all three of those inequalities are true. Therefore, this is indeed a triangle, right? Anytime you have three sides of a triangle and you find out like one of these inequalities are actually not true, um, then you can actually determine that that's not a real triangle, right? So once again, it's pretty cool because this inequality kind of tells you what can be a triangle and what cannot be a triangle. Now, a very specific question type you might get um, is you might be given a triangle, right? So, for example, we're given this triangle here, and one side is missing, and that side here is called x, and then the other two sides are given, right? So we have the sides 9 and 15, and it's going to ask you what is the range of values of x. So what can x be to make this a real triangle? In order to do that, right, it's actually really simple. All you do is you subtract these two sides that are given to you. So in this case, you do 15 minus 9, right? And that has to be less than the missing side, right? Or that has to be less than the missing side. And then the sum of these two given sides, right, 15 plus 9, that has to be greater than the missing side. And that essentially gives you the range that x can be in, right? So x can be like 7, 15, 21, right? If x was 5, this would not be a real triangle because it wouldn't lie in this range. And again, goes back to the triangle inequality theorem. If you're not sure how this connects, well, set up the sides, right? So you have 9 plus 15 has to be greater than x. You have x plus 9 has to be greater than 15, right? So from those alone, right, if you solve this, you get that 24 has to be greater than x. And from this, you get that x has to be greater than 6, right? So that's where you get this range from. And of course, you also have x plus 15 has to be greater than 9. But that will just give you x is less than negative 6. And that's not really important for this problem, right? Because you know x can't be a negative number because it's a side of a triangle. So again, in my opinion, that's a pretty cool theorem to know, right? Just in case you want to check if something is actually a triangle. Talking about triangles, right, we can also talk about another property of triangles, which is that if you're given a triangle with three sides, right, the angle that's opposite the largest side. So in this diagram, right, 25 is the largest side. So the angle opposite that side is going to be the largest angle. And likewise, right, the smallest side, which is 12, right, the angle opposite the smallest side is going to be the smallest angle. So again, that's true for every single triangle, right? The largest side is opposite the largest angle, and then the smallest side is opposite the smallest angle. Now, lastly, but most importantly, I'll go over assumptions. which are going to be really important for when you do proofs later on in this course, right? So yeah, this is a must know. You really do need to know assumptions if you want to go on and do proofs. And when I talk about assumptions, I'm talking specifically when you're given a diagram um, in a geometric question, right, or geometry question, or again, right, you might be given a diagram for a proof, and there's some things that you can assume from a diagram, and there's some things you definitely cannot assume from a diagram, right? So let's start with the first, right? What can you assume from a diagram? Well, you can always assume straight lines and angles. And what I mean by that is if you're given a diagram, right? Let's say you're given like this diagram here, and you see that there's a green line here that looks straight, right? If you can like kind of decipher that this line is straight, then you can assume that it's going to be a straight line. Therefore, you can assume it's a straight angle. So anytime you see a straight line in a diagram, you can 100% assume that it's going to be a straight angle or a straight line. You can also assume collinearity of points. Again, we talked about that, right? Of course, if you see that a line is straight and you have 3 points on it, you know those points have to be collinear because they lie on the same line. Um, Third, you can assume betweenness, right? Again, I already talked about this earlier, but if you prove that 3 points are collinear, right, or three or more points are collinear, you can definitely assume betweenness, right, or like point B is in between A and C, right? And lastly, you can assume the relative positions of points. What that means is like, again, once you determine that all 3 points or all the points in the given diagram are collinear, you can you can conclude that, for example, C, right, point C is to the right of point B, or like point A is to the left of point C, right? That's what I mean by relative positions. So those are all the things you can always assume when you're given a diagram, right? Now, there are also things that you should definitely not assume in a diagram, right? And these are arguably more important than the things that you can assume. So, first and foremost, you should definitely not assume right angles. What do I mean by that? Well, if something looks like it's a right angle, right? So you might see something like this, and you might say, well, that looks really familiar to a right angle, so therefore it has to be a right angle, right? Well, you can't assume that unless the problem specifically tells you that it's a right angle, or they indicate that with a right angle mark. You can't assume that it's a right angle just by looking at it. Same thing with congruent segments, right? If you see like two segments, right, and let's say you're given, again, this is a really simple diagram, but like let's say you're given two segments, right? They don't tell you that they don't tell you anything about these segments, right? Now they might look like they're equal in size, right? Because they visually, right, they have the same length, but again, you can't assume that unless it specifically tells you that the sizes are equal, or like the length of the segments are equal. You can't assume that this is equal to this. Similar logic with the angles, right? if you see an if you see two angles that are really similar in degree, right, so you might think like these two angles are going to have the same measure. You can't make that assumption unless they specifically tell you that they have the same measure. And lastly, right, let's say you're given a triangle, so I'm just going to draw a quick triangle here, right? Now, what do I mean by relative sizes of segments and angles? All I'm saying, let's just label these sides. Let's say this is side A, B, and C, right? You might just, by looking at this triangle, you might think like, okay, segment B seems definitely longer than segment A, so therefore B has to be bigger than A, right? Even though it looks like that, you can't assume that either, right? Unless the problem tells you. Similar logic, right? Segment C here looks like it's bigger than segment A, but you can't assume that C is greater than A, because you have no given numbers. And again, unless they tell you the numbers or they tell you in the problem, you can't assume that either. So that's really important to know when you're doing proofs, right? Because you don't want to make like the wrong steps when you're trying to prove something in the diagram, right? Um, And just to kind of like review this assumptions concept or thing, right? You can try this example diagram here, right? So basically, ask yourself and answer like, what can you assume and what can you not assume from this diagram? Okay, I'm hoping that you have tackled that those questions to you yourself. But so let's start with what you can't assume. Well, or what you can, right? You can assume. I told you that if anything looks like a straight line, it probably is, right? So in this case, all right, AC here, right? ACD, angle ACD is definitely a straight angle because it looks like a straight line, right? Similar logic. Um, Angle BCE here, right, is also a straight angle because it looks like a straight line, right? And again, there's a lot of assumptions we can make here, but kind of just to wrap it up, right? You can say something like B, C, and E are all collinear points because they lie in the same line, right? And therefore, you can also say, like, for example, C is in between B and E, right? Again, because they're all collinear. So now, what can we not assume from this diagram? Well, if you look at angle BAC, right? I'm talking about this one here specifically, right? BAC. This might look like a right angle to you, right? But you can't assume that angle BAC is a right angle, right? Now, if I was given the diagram like that, then I could assume that it's a right angle, right? Because the diagram indicates with that symbol. But don't assume that. Similar logic, right? Angle CDE here is not a right angle unless it tells you. And lastly, right, if I see, for example, right, segment CE and segment BC, right? Visually, segment BC looks like it's bigger than CE, but I can't make that assumption unless I'm given specific lengths, right, or relationships between those two segments. So that's all for this specific lesson, right? The most important thing you should definitely know are assumptions, right? And these previous things, right, collinearity and betweenness, we already kind of went over, but again, that's good to know. And triangle inequality, again, a really cool theorem to know, right? It tells you if something is a real triangle or not. But that's all for this lesson. Thanks for listening. And if you have any questions, leave it down in the comments and enjoy your day.